Assalamualaikum and good day everyone. My name is Muhammad Afiq bin RAHAIZAN and my matric number is 2010909991. My mission recording this video actually to present my open and the lab 2 and the topic is about three-phase induction motor. Introduction of what is actually three-phase motor is about. Three-phase induction motor is a device that convert three-phase input electrical energy into output mechanical power. Induction motor, also known as asynchronous machine. Actually, they have three-phase induction motor, which is squirrel cage induction motor and one rotor induction motor. Induction motor consists two main parts, which is stator and rotor. The methodology. This is my simulation circuit and I choose squirrel cage induction motor as my main character. This circuit actually I create and simulate using PCMLab simulation. As we can see the diagram, after I complete the circuit drawing in my PC, we attach a ground resistor to the mechanical electrical interface block at the motor shaft. I choose 6 value of resistance, which is I can explain later in my circuit. Simulation should be run, data should be collected and relevant graph should be created. Also we can see the flow chart. First of all, I start design the schematic using PCMLab and the data in the squirrel cage induction motor machine parameter box is set. After that, I start simulate the circuit and then R load that I use, I change it 6 times values to investigate the measurement. The R load value is I use to simulate the parameter. Next step, the graph of characteristic of squirrel cage induction motor are plotted by using Excel and performance motor are discussed. Next, the experiment will repeat by adjust the pole and repeat again until the end. Result. We can see in this table the R load that I change into 10K, into 5K, and 1K, 500 ohm, 100 ohm, and 30 ohm. The P in, as we can see, increase when we adjusting lower the R load, and also P out, VAR, VA, PF, torque, speed, I load, efficiency also increase when I adjusting the R load lower resistance. This is the graph for 10K ohm, which is have P in graph, P out, bar, torque, speed, I load. Also for 5K ohm, 1 kilo ohm, then 500 ohm, 100 ohm, and lastly graph for 30 ohm. So this is the speed torque graph, speed RPM against torque graph show the trend line for the number of 6 pole. The speed nearly constant at 1200 and decrease at the end because the R load will decrease and value of torque increase. And the graph, the efficiency R load shows the trend line for the numbers of pole in 6 is 6. The trend line shows the graph is decreasing. When the R load will increase, the efficiency will decrease. Also for P out against P in graph shows the trend line for the number of 6. The trend line show the graph is increase. When the P in increase, P out will increase also because R load was decreased. This is because the resistor has limited the power flow if the resistor value is large. So discussion from this experiment on three-phase, the characteristic of squirrel cage induction motor was observed like output power, input power, load current, apparent power, power factor, speed, torque, and efficiency. The number of induction motor poles is constant, which is 6. In the simulation circuit for three-phase, the value of R load has been changed from 10 kilo ohm to 30 ohm to test the values that have been mentioned whether the process of increase or decrease. On observation of the speed torque graph, at the beginning the graph shows a synchronous condition trend with almost all resistors showing the value of speed is nearly constant, which is 1200 rpm. As the resistor increase, the torque value will decrease. This is because the torque value will reach the zero value when the resistor value increase and the speed remains to reach the synchronous condition trend. For observation of the efficiency R load graph, the graph show a decreasing trend. It's because the value of resistor increase, the power losses will increase, causing the value of P in and P out to decrease, which is turn causes the efficiency to decrease. For the last graph on three-phase, for the P out P in graph show a directly proportional graph. It's because the value of P in and P out will increase when the value of the resistor is reduced, because the resistor serves to limit the rates of electrical flow. So that's all for me. Thank you.